Hello friends, now in this video we will see test on first chapter laws of motion. This test for 20 marks, time 1 hour. Definitely it will help you in your unit test examination. I will explain all the answers of the question in a very simple language. Now let us start. First, if body has negative acceleration, then the first option, the velocity of the object remain constant. This is not possible. If the velocity of the object constant, then its acceleration is zero. The velocity of the object decreases. Yes, when the velocity of the object decreases, then it has negative acceleration. This is correct one. The velocity of the object increases. This is not possible. At that time, the velocity, the acceleration of the object is a positive, and the last is none of the above. Here, the correct answer is the velocity of the object decreases. Therefore, if the body has negative acceleration, the velocity of the object decreases. Okay, now next question. Answer the following question. 1 mark. When is the speed of a body greater than the magnitude of the velocity of the body? Okay. When there is a change in the direction of motion of a body as the body moves along a curve or follows a zigzag path, then the speed of the body is greater than the magnitude of the velocity of the body. Okay. Now, next, question number 3. Give scientific reason. It is easier to stop a tennis ball as compared to a cricket ball when both are traveling with the same velocity. Now, this is according to Newton's second law of motion. First, the momentum of a body is product of its mass and velocity. The mass of a cricket ball is greater than that of a tennis ball. Hence, if the two balls have the same velocity, the momentum of the cricket ball will be greater than that of the tennis ball. Okay. Also, a cricket ball is harder than a tennis ball. Therefore, it is easy to stop a tennis ball than a cricket ball moving with the same velocity. Okay. Now the next question. An object moves 18 meter in first 3 seconds, 22 meter in the next 3 seconds, and 14 meter in the last 3 seconds. What is its average speed? Now here S1 is equals to 18 meter, T1 is equals to 3 seconds, S2 is equals to 22 meter, T2 is equals to 3 seconds, S3 is equals to 14 meter, and T3 is equals to 3 seconds. Now the average speed. Average speed is equals to total distance traveled upon total time taken, and that's equals to S1 plus S2 plus S3 upon T1 plus T2 plus 3. Okay, 18 meter plus 22 meters plus 14 meter upon 3 second plus 3 second plus 3 second. The total is 54 upon 9 meter per second. This is the unit of speed. And if we simplify, then you will get 6 meters per second. And this is the answer. And therefore, average speed of the object is 6 meters per second. Now next question. Question number 5. Explain the principle on which the launching of a rocket is best. Now see this here. The launching of a rocket. Answer. Launching of a rocket is based on Newton's laws of motion. When the fuel in the rocket is ignited. It burns as a result of chemical reactions, and the compressed hot gases are thrown out. You can see in these figures, that is a compressed and hot gases are thrown out with a tremendous force in the downward direction. Okay, through a small opening in the tail of the rocket. At the same time, the escaping gases exert an equal in magnitude and opposite in direction force of reaction on the rocket in upward direction. They exert force on rocket in upward direction. Okay. As this force is greater than the net downward force in magnitude due to gravity and air resistance, the velocity of the rocket increases as it moves upward. Okay, now next question number 6. Often the force equation, that is F is equals to m into a. Now we'll derive here. Let a constant force F acting on a body of mass m. We assume that the mass of the body is along a straight line. Let A be the acceleration produced by the force. Let U be the initial velocity of the body and V its velocity after time t, that is the final velocity. Now, initial momentum. We know that the momentum is the product of mass and velocity. Therefore, initial momentum of the body is a mass m into u, that is a initial velocity. Because u is the initial velocity, final momentum of the body is equals to m into v, that is a final velocity. Okay, now change in the momentum of the body, that is a final momentum minus initial momentum, means what? mv minus mu. Again, I had repeated here. Now, rate of change of momentum of the body, that is a change in momentum of the body upon time interval, that is time required to change its initial velocity u to v, and that time is t, and therefore mv minus mu, this is the change in momentum and time interval is t. We can take m as a common, in bracket v minus u upon t. But what is the value of a? A means what? The rate of change of velocity, means what? V minus u upon t. Therefore you will get here ma, that is a, according to Newton's second law of motion, rate of change of momentum is directly proportional to force, and hence this is a rate of change of momentum. It is directly proportional to force, means what? F. Now next, F is equals to, now here m is directly proportional to F, therefore we take K as a constant of proportionality, therefore we get here F is equals to K into M into A. Here K is a constant of proportionality. Okay. By defining unit force as that force which produces unit acceleration in a unit mass. Okay. Unit force produces unit acceleration in a unit mass. We have F is equals to 1 unit. If M is equals to 1 unit and A is equals to 1 unit, and if we substitute these values in this equation, then you will get here the value of k is equals to 1, f is equals to 1 unit, m is equals to 1 unit, a is equals to 1 unit, f is equals to k into m into a. Substitute 1 unit is equals to k into 1 unit into 1 unit, and overall you will get here the value of k is equals to 1. Substituting the value of k is equals to 1 in this equation, and therefore you will get here f is equals to m into a, and this is the equation of force, that is f is equals to m into a, that is force is equals to mass into acceleration. Now next, This equation is known as the force equation or the equation of motion. Now question number 7. A kangaroo can jump 2.5 meter vertically. What must be the initial velocity of the kangaroo? Now see this figure here. The kangaroo is jumping 2.5 meter vertically. Okay. Now see this here. A is equals to 9.8 meter per second square. This is acceleration due to gravity. V is equals to 0. Its final velocity is 0. And it has the velocity which is initial. That's we want to find out. S is equals to 2.5 meter. Now the kinematical equation of motions, that is V is equals to U plus AT, S is equals to UT plus 1 upon 2 AT square. Now we know A, we know V, we want to also we know the value of S. Okay, by using this we will select the third kinematical equation. V square is equals to U square plus 2AS. Substitute the value, that is a 0 square is equals to U square plus 2 into minus 9.8 into 2.5. Here we have taken the acceleration due to gravity. It has a negative sign because the acceleration is in opposite direction to that of velocity. Velocity is in upward direction and acceleration in a downward direction, and that's why we have taken it as a negative sign. Okay. Therefore, 0 is equals to u square minus 49, and therefore u square is equals to 49 and u is equals to 7 meters per second, and this is the initial velocity of the kangaroo so that he can jump 2.5 meter vertically. Okay. Now next example. In the case of a body moving along a straight line with a uniform acceleration, obtain the kinematical equations of motion by graphical method. This for the 5 marks. Now consider a body moving along a straight line with uniform acceleration a. Let u is equals to initial velocity of the body, v is equals to velocity of the body after time t, also called the final velocity, and s is equals to displacement of the body in time t. Now see this here figure. This is the u initial velocity. After time t, its velocity, final velocity is v. Okay, and it acquires the position b here. The following figure shows the corresponding velocity time graph. Okay, d and b corresponds to the initial and final position of the body. D shows the initial position, okay, and b shows the final position after time interval t. Now velocity time relation, that is a is equals to change in velocity upon time. Okay, and this is nothing but change in velocity. Up to this OD is u, and next OC is v, and therefore we will write here change in velocity. It means that AE BE minus AE is nothing but AB. This is change in velocity. Therefore, change in velocity is AB, means what? Final velocity minus initial velocity. This AB is nothing but the change in velocity upon time. Therefore, AB upon T, and hence the value of AB upon T is A. Therefore, AB is equals to AT. Okay. Next, B is equals to, this distance B is equals to BA plus AE. BA plus AE. Now see this here, BA, but A is nothing but OD. But what is the value of OD? OD is U, and the value of BA or AB is AT, and the value of BE, B to E, this is nothing but final velocity V. Now we'll substitute the value. B is equals to V. This is BE. Okay. BA is nothing but AB, and that is the AT. AE, this AE is nothing but OD, and that is equals to U. And therefore V is equals to AT plus U. And this is the first kinematical equation of motion. Now next, displacement time relation. Distance covered in time t is equals to area enclosed within ODBE under velocity time graph. Okay, ODBE. Okay, now S is equals to area of the quadrilateral ODBE, and this area of the quadrilateral we will divide into two parts. First is area of rectangle ODAE plus area of triangle DAB. But what about the area of rectangle? Length into breadth. But what is the length? Length is OE, and its a breadth is DO or AE. Therefore, OE into OD is plus 1 upon 2. Area of the triangle ABD, that is a 1 upon 2. Base into height, that is a DA into AB. Now OE means what? O to E is equals to DA, and that's equals to T. This distance O to E is a time, that is OE is equals to DA is equals to T. Therefore OE and the DA is replaced by T. This is OE and this is the DA. They are replaced by T. What about the OD? OD is the initial velocity. It's replaced by U. And next, this AB is replaced by AT, and if you replace it, then you will get S is equals to T into U plus 1 upon 2 in bracket T into AT. Okay. Therefore, S is equals to UT plus 1 upon 2 AT square, and this is the second kinematical equation. Now next, displacement velocity relation, and this is the third kinematical equation. Now see this here. S is equals to area of trapezium ODBE. ODBE. Okay, here trapezium, there is some spelling mistake. Area of trapezium ODB is equals to 1 upon 2 into sum of parallel sides. Which are the parallel sides? BE and OD are parallel sides. And what is the distance between them? Distance between them is OE. Now, what is OD? OD is equals to U, that's initial velocity. BE means what? Final velocity. OE is T, therefore S is equals to 1 upon 2 V plus U into T after substitution. Also, we know that A is equals to change in velocity upon time, means what? Final velocity minus initial velocity upon time. Therefore, T is equals to V minus U upon A, and now we'll substitute the value of this T in this equation. Then you will get here S is equals to 1 upon 2 V plus U as it is. The value of T is V minus U upon A, and now the product of 2 into A, that is a 2A, and after simplification that will become here 2AS, that is a 2 into A 2A. When it comes on the left hand side, it will multiply to S, therefore that will become 2AS, and V plus U into, in bracket, V minus U means what? A plus B into A minus B means what? A square minus B square. Similarly here, V square minus U square is equals to 2AS, and hence V square is equals to U square plus 2AS. Okay, and this is the third kinematical equation. And in this way we have completed the first test on first chapter, that is the laws of motion. Now we will see in the next video. Till then, goodbye.